So really, you guys talked last year about exponential growth and exponential decay. If you have what makes an exponential function where b is greater than 0, a can be greater than 0, and again, the variable is in the exponent. That's what makes an exponential function. So again, notice the a and b will be constants. They will be real numbers. Your variable is the exponential function. Makes it exponential growth. So what distinguishes exponential growth versus exponential decay is where b is greater than 1 and positive. So if you have an exponential growth function, your b value has to be greater than 1. So the base is going to be greater than 1. Also, there can be no negative exponent. So before you decide whether or not you've got an exponential growth versus an exponential decay, make sure if there is a negative exponent, you rewrite it with a positive exponent first, because that may change the b. Instead of being greater than 1, it may be between 0 and 1, which we'll talk about in a minute. So for example, let's take a look at 2 to the x. Notice your b value is 2. So we know that b is greater than 1. So therefore, we know that 2 to the x is what's going to be called an exponential growth. Your variable is a positive x, the base is greater than 1. So remember, the way you graph an exponential function, parent function, you just pick 3 x values using -1, 0, and 1, and plug them into the function. What happens when I take 2 and raise it to the negative first? If I rewrite that without a negative exponent, what is 2 to the negative first equivalent to? 1 over 2. 2 to the 0 is equal to what? 1. 2 to the first is just what? 2. So when I plot those points, I have -1, 1/2, 0, 1, and 1, 2. Remember, with your exponential functions, you have horizontal asymptotes at y equals 0 for the parent function. And the graph gets really close to the asymptote, and as your x values increase, so do your y values. So again, just some characteristics of your exponential functions. Remember, you have a horizontal asymptote at y equals 0. Your y-intercept is going to be when x is equal to 0. And for the parent functions will be at 0, 1. Your domain, remember, is going to be all real numbers. The range for the parent function, again, you've got the asymptote. Your graph is getting really, really close to the asymptote, but it's not crossing or touching it. So it's going to be 0 to infinity. Yes, Emma?
How do you know the asymptote is 0?
Again, remember, I can plug in, no matter how small I make x, like this could be -1 million. Because it's a negative exponent, I'm never going to get a value close to 0. I'll never get something equal to 0. It'll be really close to 0, but it will never equal 0. Nor will I get a negative output for this. So therefore, that's creating a horizontal asymptote as your x values go towards -infinity. Okay? So any questions on the exponential growth graph? So now exponential decay. It's still an exponential function. However, your base is going to be a fraction between 0 and 1. And again, b is positive. And again, make sure you have no negative exponents. So like I said, before you decide whether or not it's exponential growth versus exponential decay, make sure that if you need to, you reciprocate, you flip that fraction. So for example, here is 1/2 to the x. Notice this is going to be exponential decay. Your variable that's in the exponent is not negative. But notice the base of 1/2 is a fraction which is between 0 and 1. So that's what creates an exponential decay function. Just like we did for 2 to the x, when you take 1/2 to the x, again, these are your parent functions for exponential functions. Again, you're going to use an x value of -1, 0, and 1. Now what happens when I take 1/2 and raise it to the negative first power? 2. 1/2 to the 0 is going to be what? 1. And then 1/2 to the first is just going to be 1/2. So when I plot those points, I have negative 1, 2, 0, 1, and then 1, 1/2. So notice what happens is my graph is now decreasing. I still have that horizontal asymptote at y equals 0. So again, the characteristics are very similar to for the exponential growth. You still have an asymptote at y equals 0. Your y-intercept, notice, is at 0, 1. The domain is all real numbers, and the range is going to be greater than your asymptote. So whether it's exponential growth or exponential decay, the characteristics of the graphs of the parent functions are going to be the same. So any questions on how you graph an exponential growth or decay or an exponential function? And now, of course, if you're comfortable with the parent function, we can start shifting these things around, moving them up, down, left, and right. So for example, let's take a look at 10 to the x. Is 10 to the x going to be a growth or decay? Growth. Now, just because you see a fraction, be careful, does not automatically mean that it's going to be a decay. Look at 3/2 to the x. Is 3/2 greater than 1 or less than 1? Greater than 1. So is 3/2 to the x going to be an exponential growth or an exponential decay? Growth. And look at this example. We already know 1/2 to the x is a decay. What about 3/4 to the x? Is 3/4 to the x going to be an exponential growth or an exponential decay? Decay. So let's take a look at A. Tell me whether or not these are exponential growth or exponential decay. Look at A. What do you think? Is this going to be a growth or a decay? Decay. Remember, the 5 is just going to be affect your vertical stretch or compression. What you're looking at is you're looking at the base that has the variable as an exponent. And again, since we know that 2/3 is a fraction between 0 and 1, it's got to be a decay function. You guys go ahead and do, what do you think about B? Growth. Again, because we know that 3/2 is greater than 1. Now be careful in letter C. Like I mentioned, before we decide whether or not this is growth or decay, you've got a negative exponent. So you've got to rewrite this so that you have a positive exponent. So what's going to happen when I take the reciprocal of 3? What is the reciprocal of 3? 1/3. So again, before you decide whether or not it's growth or decay, if you have a negative exponent, make sure you rewrite as a positive exponent. So now what is this going to be, growth or decay? Decay. Okay? Again, just make sure anytime you see a negative x, before you decide if it's growth or decay, make sure you rewrite it with positive. So now let's start shifting these things around. So my parent function is 2 to the x. So now let's be comfortable looking at the transformations. What's this plus 3 going to be doing in the exponent? Well, anytime you have a number added or subtracted to x, that's your shift going left or right. So what's this plus 3 going to do to the parent function? It's going to move it where? Left 3. And again, you have 1/4 being multiplied by the function. So that's your vertical stretch or compression. So again, this is going to be a vertical compression by 1/4. So now look at B. What's the minus 3 in the exponent going to do? It's going to move it to the what? Right 3. And the minus 4 is going to make it do what? Down 4. So any questions on identifying shifts with the exponential functions? All right. So now let's do some graphing. First of all, identify the parent function. Well, I know the base. What's the base of this exponential function? The base is going to be what? 4 raised to the x. So always identify the parent function first. What's your transformation going to be? Your transformation is going to be where? What's your transformation going to be, guys? Right 1. So again, if you want to look at the graph before you decide about filling in all this other information, you can certainly do that. Again, so looking at your table of values, here's my parent function, 4 to the x. Again, I'm going to use the same x values, -1, 0, and 1. What's 4 to the negative first? 4 to the negative first is what? 1/4. 4 to the 0 is 1. 4 to the first is 4. Now, these are the parent functions. So now to graph 4 to the x minus 1, I need to take each of these points and I need to shift them to the right 1. So depending upon how you feel comfortable doing this, when I move something to the right 1, what I'm doing is am I going to be adding 1 to the x values or adding 1 to the y value?
Y.
Again, I'm going to the right, x values. So negative 1 plus 1 will give me 0, 1/4 as the new point. 0 plus 1 will give me 1, 1 as the new point. And then 1 plus 1 is 2. So then my next point will be 2, 4. Or, like I said, you can just take your pencil, go to negative 1, 1/4, and then just take your pencil and shift it to the right 1 that way, depending upon which way you feel more comfortable doing. So again, at negative 1, 1/4, I shift it to the right 1, which puts me at 0, 1/4. 0, 1, when I shift it to the right, will put me at 1, 1. 1, 4, when I shift it to the right 1, will put me at 2, 4. Did my asymptote change?
No.
When I move everything? No. So I still have my asymptote at y is equal to 0. So again, like I mentioned, my asymptote is still at y equals 0. What about my domain? Did my domain change?
No.
Nope, the domain's still going to be all real numbers. Remember, no matter what shifting I do, I can never change a domain from a parent function of all real numbers to anything else. What about the range? When I shift it to the right 1, did that affect the range? Nope, that's going to be 0 to infinity.
We just ran all real numbers.
That's fine. Now, limits. We just got done our unit on limits. So now take a look at the graph. The limit is x goes to infinity. What side of the graph am I looking at, left or right?
Right.
To the right. What's happening with the behavior of this function as I'm approaching infinity? It's going towards what? Positive infinity. The limit as x approaches negative infinity. What side of the graph am I looking at? Left. Now, what's happening on the left? It's not pointing up. It's going towards what? It's approaching your asymptote. So what's the limit as x goes to negative infinity going to be? 0. So now notice this is a case where one side of your graph is going to be going towards positive or negative infinity, and the other side is going to be approaching that asymptote. Is this increasing or decreasing? Increasing. There are no intervals that I'm decreasing. Okay? So any questions on that one? Let's take a look at number 3. What's the parent function in 3 going to be? 1/3 to the x. What's the minus 2 going to be doing to the parent function? It's going to make it move where? Down 2. And what's the negative sign in the front going to do? Reflection over x. Shh. Okay? So any questions on the transformations? Well, if I'm taking this graph, ladies and gentlemen, and I'm shifting it down 2, what's that going to do to my asymptote? It's going to make it do what?
Drop 2.
Go down 2. So my asymptote, remember, is going to be moved anytime you have a function shifting up or down. So my asymptote is now going to be at y is equal to negative 2. So again, I can build my t-chart for my parent function. 1/3 to the x. Again, using those x values of negative 1, 0, and 1. Well, what is going to happen with 1/3 raised to the negative first power? 1/3 to the negative first is just going to give me 3. 1/3 to the 0 will be what? 1. And then 1/3 to the first will be 1/3. So now, if I want to reflect across the x-axis, that's going to change the values of the y-coordinates. So when I change the values of the y-coordinates, I'm just simply going to flip the sign. So to come up with the reflection over the x-axis, all I'm going to do is I'm going to change the sign of my y-coordinates. That takes care of the reflection over the x-axis. So remember, reflection across the x-axis Again, when you are moving over the x-axis, that's affecting the signs of your y-coordinate. So all I have to do is flip the signs. But now, after that, I want to shift everything down 2. Well, when I shift everything down 2, is that going to affect the x-coordinates or the y-coordinates? The y-coordinates. I'm simply going to subtract 2 from the y-coordinates. So that's going to give me a -1. -3 minus 2 is a -5. -1 minus 2 is going to be a -3. And then I'll have 1 and then -2 and 1/3.
Bless it.
Or like I said, if you're more comfortable, what you can do is just take the points on the parent function, -1, 3, reflect them, and then move them down 2. It's just whatever you feel more comfortable doing. So again, I have my point -1, 3. I reflect it over the x-axis to -1, -3, and then move it down 2, so that'll put me at -1, -5. 0, 1, reflected to 0, -1. And then I shift it down 2, which will put me at 0, -3. 1, -1/3. And then I shift that down 2, that'll give me -2 and 1/3. Okay. Remember, you always reflect, guys. You always reflect before you shift up, down, left, and right. Okay? So now tell me, what's the domain of this function going to be? The domain's going to be what? All real numbers. Now the range is going to change because you have the reflection as well as shifting it up or down. Now, is the range going to be greater than -2 or less than -2? Less than -2. So it's going to be -infinity to -2. Limit. As x approaches positive infinity, remember I'm looking at the right-hand side of the graph. So on the right-hand side of the graph, what is this graph approaching? It's approaching what? -2. And as x approaches -infinity, you're looking on the left-hand side of the graph, and that's approaching what? -infinity. Is this graph increasing or decreasing? Increasing. So again, it's going to go from -infinity to positive infinity. And there's no intervals of decreasing. Remember, we talk about increasing, you read a graph just like you read a book. Starting on the farthest left-hand side of the graph. Take your pencil and trace it. If your pencil's going up, we say it is increasing. Yes, Emma? For increasing? Because again, if I start all the way over here on the left and I trace it, my y values are getting larger and larger and larger. Read a graph just like you read a book, left to right. Okay. Any other questions on graphing this with transformations? Kind of remember doing that last year a little bit? If you can graph an exponential, you can graph a log. Like we just got done doing, an exponential function. Again, we're going to use a graph of 10 to the x, use a base of 10. The domain, remember, of all exponential functions is all real numbers. The range is going to be greater than 0. Your horizontal asymptote was at y equals 0, and then remember we have the x-intercept at 0, 1. Remember a characteristic you studied last year. Exponential functions and logs are inverses of one another. What does it mean to be an inverse? How do you find an inverse? What do? You switch what?
Oh, wait, no.
How do you find inverse of functions? You do what? You switch what?
1 and...
X and y. Remember, to find an inverse, you switch the x's and y's. So when you're looking at an exponential function, if your exponential function has a 10 as the base, the log function will have a base of 10. And remember what happens with a function and its inverse. If x's and y's switch, what happens with the domain and range? The domain and ranges are also going to do what? Switch. So since the domain of your exponential function is all real numbers, the range of your log function will be all real numbers. Since the range of your exponential function is 0 to infinity, the domain will be 0 to infinity. Instead of having a horizontal asymptote at y equals 0, since I switch x and y, What kind of vertical asymptote is this going to be? This is x equals 0. Again, your intercept for the exponential function was 0, 1. The intercept on your log function when I switch x and y is going to be 1, 0. With with log functions, ladies and gentlemen, the common base is 10. So for an exponential function, you would see it as 10 to the x. So for logs, log base 10 of x, we do not write, you will not see a base 10 ever written.
Okay.
So that's the common base. So when there's no subscript 10, we know that it is a base of 10 logarithm. The natural base is e. Do you remember what the value of e is?
3 point something.
That's pi.
Oh, wait. I swear to God, it's 3.
It's about 2.7. It is close to 3. Remember, e is that natural number. It's approximately equal to about 2.7. So for an exponential function, e to the x, we won't see log base e of x written. We see y is equal to the natural log of x. Remember, natural log of x is just a logarithm with a base of e. So the way you graph a log function is you always graph the inverse exponential first. Then you switch everything around. So for example, we know 10 to the x. If I graph 10 to the x, building my table, I've got my x and y chart, negative 1, 0, 1. 10 to the negative first is 1/10. 10 to the 0 is 1. 10 to the first is 10. Right? So now, to figure out what's going to happen with the log graph, all I'm going to do is I'm going to switch the values in my table, switch those x and y values. So for my exponential function, I had negative 1, 1/10. So again, I'll end up with 1/10, negative 1 on the log graph. 0, 1, when I switch it, will go to 1, 0. 1, 10 will go to 10, 1. Okay. So if you take a look at the graph of 10 to the x, I know that was negative 1, 1/10, 0, 1, and 1, 10. Ask me what?
Who came up with this?
Logs?
Yes.
The Greeks.
We're just
Probably the Greeks, I don't know.
Well, I'm just gonna flip
We'll do
this.
some research. I'll answer you Wednesday, Jay.
All right, thank you.
Yes, Joanna?
Oh, wait, never mind.
Okay. So, ladies and gentlemen, remember the domain of exponential functions are all real numbers. The range is 0 to infinity. Your asymptote, remember, if the parent function is y equals 0. And as we can see, the limit as x goes to positive infinity, it goes to infinity. The limit as x goes to negative infinity goes towards the asymptote. So now let's take a look at graphing your log function. So when I take the first point, 1/10, negative 1. 1, 0, 10, 1. So there's your log of x. This is your 10 to the x. Remember, a function and its inverses are reflections over that line y equals x, which you can see you have. Remember, the domain and ranges are going to flip. So since the domain for exponential is all real numbers, the range for my log will be all real numbers. Since the range was 0 to infinity, the domain for my log function is 0 to infinity. And you can see you have a vertical asymptote at x equals 0. So now the limits are a little different with the log functions. So again, notice the questions ask you the limit as x approaches 0 with a plus sign. What side of 0 are we looking at, left, right, or both?
Right.
To the right. So again, take your pencil, go to the right of 0, trace your log graph. What's happening with the behavior as you're approaching 0 from the right? You're going down towards what?
Negative.
Negative infinity. But the limit as x approaches positive infinity, no, it's increasing. It's increasing at a slow rate, but it is going towards infinity.
Oh.
But like I said, when you graph a log, you always start with the exponential function first. Then you switch those values in the table. Kind of remember doing this a little bit last year?
Not at all.
Wonderful. So let's take a look at e to the x. Okay. Remember, ladies and gentlemen, e is about 2.7. So, ladies and gentlemen, when I take e and raise it to the negative first, I know it's going to be a fraction of 1 over 2.7. And remember, that first point you always have to approximate anyway. You know it's going to be a point somewhere between 0 and 1. Anything to the 0 power is always 1. So e to the 0 is 1. And then e to the first, I know it's going to be about 2.7. So again, on e to the x, I have that point negative 1, 1 over e. I know it's a point between 0 and 1. You have 0, 1, and then 1 about 2.7. So there's your graph of e to the x. Remember, natural log of x is a log base e. So again, to find your points on natural log of x, remember you're simply going to switch the x and the y values. So remember on e to the x, I had the point negative 1, e to the negative first. So that's going to be e to the negative first, negative 1. 0, 1 will go to 1, 0. 1e will go to e1. So again, that e to the negative first, remember it's going to be a fraction between 0 and 1 and negative 1. 1, 0, and then about 2.71. So there's your graph of natural log of x. So any questions, guys, on how you can graph the ln of x or the e to the x? Again, just like all the other exponential parent functions, the domain is all real numbers. The range is going to be 0 to infinity. The domain and range for the log function switch. The domain will be the same as the range of e to the x. That's going to be 0 to infinity. The range will be all real numbers for natural log of x. Remind me again, what's the asymptote going to be for e to the x? For the exponential function, it's going to be what? Y equals 0. For the log graph, it's going to be what? X equals 0. You guys go ahead and do the limit part for me. Everybody get those as the limits? Okay. So any questions, guys, on graphing parent log functions? So we did 2 parent log functions. We did log base 10 of x, and then we did the natural log of x. So let's take a look at number 5. First of all, what you want to do when you want to graph a log, you always identify the parent exponential function. So look at the base of this logarithm. What is the base of this logarithm? 3. So then I know that the parent log or exponential function is going to be the same base as the log, which will be a 3 to the x. So your parent log function is going to be log base 3 of x. The base of the log is the same as the base of the exponential. So now identify your transformations. What's the plus 1 inside being added to x going to do? The parent function is going to shift it where? So left 1. And then what's that plus 2 on the outside? It's going to shift it where? Up 2. So again, if you want to do the graph first before filling everything else out, that's fine. Again, fill out your table for the parent exponential function, which is 3 to the x. So fill out your table for 3 to the x first. So again, remember the x values that I use, -1, 0, and 1. So always start with that exponential function first. So what's 3 to the negative first? 3 to the negative first is 1/3. 3 to the 0 is 1, and then 3 to the first is 3. So if I know the key points on 3 to the x, I can find my key points on the parent function log base 3 of x, because what am I simply going to do with these x and y values? I'm going to do what? Switch them. So this will be 1/3, -1, 1, 0, and 3, 1. So now remember, for logs have a vertical asymptote at x equals 0. Well, you told me that I'm shifting this graph to the left 1 and up 2. So if I have a vertical asymptote at x equals 0, and I'm going to shift it to the left 1 and up 2, where's the new vertical asymptote going to be? Well, moving it up and down, does that shift the asymptote? If I have a vertical line, I shift it up and down, does that change it from x equals 0?
It does.
No. But if I shift it to the left 1, is that going to move it? Yeah, so where's the new vertical asymptote going to be? X equals -1. So now, remember, any time that you have a vertical asymptote with a log function, remember, a vertical line is going to be shifted when you move it left and right. So now, again, if I shift it to the left 1, remember, I'm going to subtract 1 from each of my x coordinates. So again, 1/3 minus 1 is going to give me a -2/3. Again, 1/3 minus 1. Because again, when I shift it to the left 1, that's affecting my x coordinate, so I'd subtract 1. 1 minus 1 is going to give me a 0. 3 minus 1 will give me a 2. So now the y coordinates are shifted by moving it up 2. So if I'm moving my points up 2, what am I going to do each y coordinates? I'm going to add what? 2 to the y coordinates. So I'll end up with -2/3. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. So remember, you want to subtract 1 from your x coordinates, and then we add 2 to the y coordinates. Or like I said, you can take the points in the parent function and just count on the grid if you're more comfortable doing that. So again, I have 1/3 -1 that I'm going to shift to the left 1 and then go up 2, which puts me at -2/3 1. I have the point at 1, 0 that I shift to the left 1 and then go up 2, so that puts me at 0, 2. 3, 1, when I shift to the left 1 and then go up 2 is going to put me at 2, 3. So there's the graph of that particular log. Now what's the domain of this log curve going to be? Take a look at the graph that we just did. The domain's going to be what? -1 to infinity. Do I put a bracket or a parenthesis before -1? Parenthesis. What's the range going to be? The range is going to be what? Range will be what? All real numbers. What's happening with this graph as x is approaching -1 from the right? So again, as you're approaching -1 from the right, I put my pencil to the right of -1. I trace my graph. As I'm getting closer and closer to -1, what am I approaching? I'm approaching what? What am I approaching? The graph is continuously going down, so what's happening? I'm going down towards negative infinity. But now as x is approaching infinity, I'm looking at the right-hand side of the graph, which means I'm going towards infinity. Yes, Emma?
Why do you have to have these two tables if you're not only going to use one?
This gives you the values that you switch.
Oh, okay. So it's just a kind of a guide.
It's easy. Yeah, it's easier to evaluate an exponential function than it is a log. Is this graph increasing or decreasing? Increasing. And what's the interval that's increasing? It's increasing from what? Negative 1 to infinity. Remember, you use the x values. Okay? So any questions on that one? All right. What's the parent exponential function going to be in this one? What's your parent exponential in 6?
X minus.
What's the base of this logarithm? The base of this logarithm is what? E. So it's going to be e to the x. Your parent log function then is going to be natural log of x. So you guys go ahead and do that one for me. See how you do. Okay, guys. So hopefully you came up with this. Again, the transformations are going to the right 2 and down 3. Shh. Any questions, guys, on graphing this natural log function? Yep. Tim. That's fine. If you put 2.7, that's fine. Any questions, guys, on the... Yeah, Joanna?
How is the limit, the top limit negative infinity? Because I put positive infinity.
So again, remember how we do limits? We're going to go, what, to the left or right of 2?
To the right.
So I go to the right of 2, and I want to trace my graph. And again, as I'm getting closer and closer to 2 from the right, what direction is this graph doing? Okay? Any other questions on that? All right, let's take a look at the last one, number 7. So remember, the parent exponential function is going to be whatever the base of this log is. So what's the base of this log? 4. So my parent exponential function is going to be 4 to the x. So my parent log function is going to be log base 4 of x. So now what's this minus 1 doing to the parent function? The minus 1 is going to make it do what? Go where? Right 1. The plus 2 is going to make it do what?
Go up to.
Up 2. What's the negative sign in the front going to be? It's going to make it what? Reflect. Okay? So any questions on that one? So let's start by building my table for 4 to the x. Still using those same x values, negative 1, 0, and 1. So 4 to the negative first is 1/4. 4 to the 0 is 1. 4 to the first is 4. So any questions on getting the table for 4 to the x? So now I can switch the x and the y values to come up with the points on log base 4 of x. So 1/4, negative 1, 1, 0, 4, 1. So now, when I reflect over the x-axis, remember you always take care of reflections before you go up, down, left, or right. When I reflect over the x-axis, what coordinate is going to be changing signs, the x-coordinate or the y-coordinates? The y-coordinates. So again, I need to change the sign of all of my y-coordinates. So that's going to be 1, 0, negative 1. So now, if I'm going to go to the right 1, I have to add 1 to each of my x-coordinates because I'm going to go to the right 1. So 1/4 plus 1 will put me at 1 and 1/4. 1 plus 1 is 2. 4 plus 1 is 5. If I go up 2, what am I going to do to each of those y-coordinates? I'm going to do what? Add 2. Remember, I'm using the ones where I've already reflected the y-coordinate. So 1 plus 2 is 3. 0 plus 2 is 2. Negative 1 plus 2 is 1. By the way, where's my asymptote going to be? If I shifted this graph to the right 1 and up 2, where's the new vertical asymptote going to be? Positive 1, x equals 1. So 1 and 1/4, 3 is my first point. 2, 2, 5, 1. So this is what a graph looks like of a log function that's reflected over the x-axis. What's the domain going to be for this? The domain is going to be what? 1 to infinity. Range is going to be what? Range is going to be all real numbers. Now, what's happening with this function? Is it increasing or decreasing? Decreasing, and it's decreasing from my x values of 1 to infinity. So now let's talk about the end behavior. The limit as x approaches 1 from the right. The limit as x approaches 1 from the right, what's the behavior of this graph? It's going towards what? Positive infinity. The limit as x approaches infinity, what's the behavior of this graph going to be? What's the behavior of this graph? Negative infinity. So any questions on how you graph the log or the exponential functions?
No.
All right, so hopefully that's a reminder. Hopefully it